First by South India, which Geeta is going to do, and the second by Sri Lanka. Both presentations are loaded up and ready to go. So without further ado, we'll invite Geeta to come up. I'd like to remind the speakers they have a maximum of 20 minutes and then allow 10 minutes for discussion. If you want to finish before 20 minutes, I'm sure that would be appreciated. I'll just tell you when there's about 3 minutes.
Good morning to all of you. I'm happy to present the report of South India, and I'm pleased to acknowledge my team members' contribution for making this presentation, and also the resource person's contribution. The thing is, I just would like to give you some overview about the baseline agro-climatic analysis of the regions which we have done for the fast track, and which we are also going to do the extended analysis. This slide shows the growing season, which is September-October to December-January, which is basically northeast monsoon season for the rice crop in Adaptation region of Tamil Nadu. So this is our major growing season, so we thought we can just put up this. So the black color lines are showing the baseline yield in all the three graphs. So these are the baseline yields in all the three graphs, and we try to find out what relationship it has with the baseline rainfall as well as the minimum temperature and the number of rainy days. The reason why we have put this minimum temperature is we found a much relationship, better relationship compared to maximum temperature. So we have just put that minimum temperature in this for the presentation. So if you just see that there is a good relationship between the amount of rainfall as well as the number of rainy days and the yield. So this is quite a positive relationship. But if we just see the minimum temperature, it is the opposite relationship we could find. Whenever there is an increase in minimum temperature, the yields are decreasing, and whenever there is a dip in minimum temperature, the yields are better. So there is a lot of things which we can think of when we are doing for the future as well. So the same analysis we have done for the Mehboob Nagar of Andhra Pradesh. And here one interesting thing is we could see that the relationship, there is a shift from this stage onwards. That is from 1995 onwards, there is a shift occurring in the relationship when compared to the previous years. So the same thing like in the rainfall, there is a positive relationship, and there is a number of rainy days also positive relationship, but there is a negative relationship with the minimum temperature, but there is definitely a different kind of a relationship which is existing in this part of this graph. So the group just tried to identify what was the reason, and according to Dr. Raji Reddy and Murthy, we could see that when we see the probability of exceedance of 50% water stress level in the earlier days between 1971 to 80 and compared to the recent time, the stress days are increasing towards the reproductive stage, which is actually the reason for the differential relationship when we just compare the previous decades. So having done the baseline analysis, we just wanted to see what is happening to the spread of temperature and rainfall in the 20 cm IP5 GCM simulation of the mid-century with RCP 8.5. And this is for Tamil Nadu. We have done it for both the seasons because we are planning to do it for both the rainy seasons, and also this is for the Mehboob Nagar of Andhra Pradesh. And when we just compare the southwest monsoon of Andhra Pradesh, so this is our current situation, we could see that there is a shift in temperature towards the positive side. That means that all the models are projecting increase in temperature. At the same time, as far as Andhra Pradesh southwest monsoon is concerned, that's June, July, August and September, we could see that there is going to be increase in rainfall, which is shown by most of the models. One important thing which we could see it from this particular graph is a lot of models are congregated to one side, which means the variability is much lesser compared to the Tamil Nadu place. Here, this is the one, the I is the one which we will be taking up for our future analysis. Coming to Adaptation region of Tamil Nadu, this is our major rainy season, which is northeast monsoon, October through December, but we are also considering September because our sowings are starting in September and it is ending in December or January of the next year. So we could see that some of, though all the models are showing positive shift as far as temperature is concerned, but there are few models showing lesser than average rainfall of the current conditions. So these are the models which indicate that the rainfall is going to be lesser during the growing season. But by and large, most of the models are showing increase in rainfall. But if we see the spread is actually larger compared to the Andhra Pradesh. Though both the places are having very less rainfall, but as far as the variability is concerned, the Tamil Nadu region is going to be much more variable compared to this place. And this is for the southwest monsoon, again because we are going to take up the irrigated maize crop for southwest monsoon, so we have looked into the same kind of thing and it indicates almost a similar thing, but as far as variability is concerned, southwest monsoon is much stable compared to northeast monsoon. Okay, so the next thing what we did was, we tried to compare the baseline with the future climate, again with the RTP 8.5 mid-century temperature scenarios. This is the mean temperature scenarios we looked into. So this box indicates the seasonal and this one is for the annual. So we could see that as far as Mehboob-Nagar is concerned, this is the southwest monsoon dependent place. The rainfall in southwest monsoon is going to be increased. It's going to, this is the temperature, this is the temperature. So the temperature in the growing season is going to be elevated compared to the other seasons. So here we have to be very cautious because when the temperature is increasing, naturally whatever the rainfall increase is happening or carbon dioxide increase is expected, that will get compensated because of the increase in rainfall. So coming to the monthly distribution as well, so starting from, this is the June month, June, July, August, September, wherein the major growing season is happening. We could see that always there is a shift in all the months, but the same thing is happening in the growing season as well. So this is the precipitation. So in this precipitation, one important thing is there is a shift in rainfall. If you could just see, this is the southwest monsoon rainfall and this is the northeast monsoon rainfall. So as far as Mehboob-Nagar is concerned, some amount of rainfall might go into northeast monsoon as well. So there may be a variation in the growing season. The other important thing which we could find is, within the growing season, the June month is expected to get more rainfall, which is starting of the growing season, which the crop doesn't require that much rainfall. But whereas in the other months, July, this is the at present peak rainfall month, July, August, September, the rainfall is going to be either as of current level or going to be little lesser than the current level as far as that I is concerned. It is the GFDL ESM2M model is concerned. So this is the kind of thing which we expect. And for Tamil Nadu region, so this is the temperature shift. We expect a higher temperature in all the seasons. And also in the annual, especially in the two growing seasons, the temperature shift is going to be higher compared to the rest of the season. And the rainfall is concerned, this is our peak rainy season. By and large, the model is predicting the same trend in the future as well, but we are going to get maximum rainfall, especially our peak rainy season is in the month of November. So in the November month, the rainfall is going to be much more higher than what is happening now. So already we have some flooding problem in that particular region, so we need to look into the distribution in this particular case as well. So this is mainly, this slide was done for the economist to look into. So what is happening to the anomaly as far as temperature and rainfall are considered. This is for the Tamil Nadu region. So this is the anomaly from baseline to future, and we could see that the rainfall, as far as the rainfall is concerned, in the southwest monsoon 6, 7, 8, 9, which is June, July, August and September, the rainfall is going to be lesser than the baseline. But at the same time, the temperatures are increasing in all the cases. Even in the growing season, the temperatures are expected to increase. And this is our major growing season, October, November and December. We are expecting more rainfall during this time. At the same time, the temperature is also going to be increased at this particular part of time. And this is for Andhra Pradesh, the southwest monsoon dependent rainfall period. So as I already indicated, the June is going to get maximum rainfall, July, August lesser than average, and again in the end of the growing season they get little bit above rainfall. At the same time, the temperatures are also expected to increase. So this is the relative yield distribution. We could see that for Tamil Nadu region, the relative yield distribution is something around 0.95. So if you could see, this is the one which is the current condition. So we could see that by and large it is actually oscillating between 0.95 and 1. And whereas in Andhra Pradesh, it is much spread out, and there is also above 1 to 1.05, and most of the things are falling between 0.85 and 1. So this is about the relative yield distribution. And when we compare the gains and losses, the gains are about 45.3% in Tamil Nadu, whereas the losses are 54.7% in Adurai case, in Tanjore region. Whereas this almost same kind of trend is found in the maize crop in Andhra Pradesh. The gainers are 46.8%, whereas the losers are something 53.2%. So this is the summary of the economic analysis. And the parenthesis, it's indicating the standard deviation values here, but these are the yields in kilograms per hectare. This is the time average relative yield. So the same thing could be seen here as well. So the time average relative yield is 0.9508, and future projected yield is 5087, whereas the base period yield is 5388. So when we just compare this, the net change is going to be a loss of something 3.09% is the loss expected. So the same way we did it for Andhra Pradesh as well. For the mid-century RCP 4.5, this was the time period taken by us for the analysis, and we could see that the time average yield is 0.9720 with future yield of 3189 and the base period yield of 3264. Here again, when we see the net change after comparing the gain and loss, the loss is 3.60%. So this is the result we could see from the economic analysis. Okay, so far I've just narrated what we have done in the fast track analysis. Now I would like to go with the home stretch thing. So as far as Tamil Nadu and Andhra Pradesh are concerned, we have decided with the crops and the area. So this is what we will stick on to when the home stretch is concerned. So we will take up irrigated rice crop in Tanjore, so which we have done it in the fast track with 30 farmers, but we would be taking up 90 farmers and we would complete the analysis. And maize in Coimbatore as irrigated, and then rain-fed maize again in Coimbatore. So maize crop we will be taking up both under irrigated and rain-fed condition. In Andhra Pradesh, they will be definitely doing the maize crop for Mehboob Nagar, but if time permits and if time available, they would also attempt to do rice crop in Krishna Delta. So this is the holistic view or approach to address climate change or variability. We are just thinking of putting that cropping system diagram by including the animal component. As far as the Tanjore region is concerned, paddy is the main crop, but they also grow the black gram as the rice fallow pulse. And we try to link the resources from one to other. For example, the food is coming from the crops to the farm state, whereas the labor and capital are going here. The same way, the nitrogen fixation, fodder and manure exchange, everything is happening. This we try to put it in the thing and find out what is the net gain and loss. And the similar way, they have also attempted to do it in Andhra Pradesh, but this we will be rectifying this. But we will be seeing both the system 1, system 2, and also with adaptation we are planning to do this. Okay, so these are the adaptation packages we thought of. As far as the crop model side is concerned, we are thinking of 4 major adaptation practices, mainly the water management. Our area is constrained with water, so we just wanted to give importance to water management. For as far as maize crop is concerned, just giving 1 or 2 protective irrigations to rain-fed maize at critical stages, what impact it would have, we just wanted to find out and link it as an adaptation package. The same way in the rice, adjusting the irrigation depth at various phenological stages. Maybe not following the same 5 centimeter depth, we would try to restrict the amount of water in the earlier stages and at the late stages, but we would keep more water for the flowering to grain filling stage, which is very critical for the rice crop. And then varietal changes. As far as rice is concerned, we try to change to some of the short duration variety, considering the delay in onset of monsoon that's happening quite often. And then nitrogen management, we try to think of split application and also varying the amount in both the cases, maize and rice. And coming to dates of planting, either advancing the planting dates or delaying the planting dates depending upon the model results. And in the economic model, we try to have farm area allocation. like water stretched crop as well as water intensive crop. So this kind of variations also we would think of, and also substitution of labor and mechanization. So this may also change the cost of cultivation. So this kind of things we try to think of. So this is our delivery timeline we just wanted to try. So these are different months we are thinking of. In August 2013, we try to go with the economic data collection for both Coimbatore and the method and validation of DSAT model. So at the end of this month, we try to have crop coefficients done for those varieties which we try to add up. And then in the month of September, we want to do the APSIM workshop, including dough, and so that we can done with the calibration and validation of APSIM, so that we can try both the models. And we will also do the courses for global workshop and submit it to the leaders for consideration. Then in October 2013, we try to do the book chapter draft and capacity building programs to the regional researchers. So here, draft book chapter will be done and the capacity building report we will send it. And in November, good time for completing the postage, and paper presentation in ASA will also be completed. And in December 2013, we would run the model and analysis and interpretation of the data, development of adaptation practices for the climate change scenario, and then we would also go with adaptation toolbox or packages for respective systems. So this is our idea. And in January, we try to have stakeholder engagement and a writing workshop. Maybe this might be shifted to December end also. The technical brief, policy briefs, and final book chapter would be ready by January 2014. And in February, we want to have final report preparation and publication. We will be submitting the final report. At the same time, we are planning for 3 research journal articles, one for each crop, rice and maize from both things, and one from the economic side. So this is our plan of the deliverables and timeline. And this is my last slide, ideas of extension. So the first thing is the rice and maize are major crops which is grown in a stressed environment in both the states, maybe like rain-fed and canal water dependent kind of thing. So we just wanted to have a large area analysis, like either agro-climatic zone level or at the level of something kind of not as a district but as a state as a whole, so that we can develop. Another important thing is developing genetic coefficient, taking inputs from the ongoing projects and programs, and trying with some of the field trials as well. Then validation of selected adaptation technologies in analogous locations is another idea, and then developing vulnerable maps for effective policy intervention. So when we do the state level analysis, we can just develop for each crop which are the areas that are very vulnerable to the changing climate, which will impact that particular crop. So we can do the vulnerability mapping, and which we will be providing it to the policymakers for policy intervention. Then dissemination of climate information and adaptation packages to a range of stakeholders, starting from the farmers until the policymakers, we just keep in mind. And then organizing capacity building programs to other researchers, then developing form panel data sets. So this came from the economic side, and exploring the possibilities of involving other disciplines, for example, entomology, pathology for pest and disease, and then water technologies for including hydrological model into this analysis, and then physiology people as well. So this is our idea for the extension. I think that's all I have for presentation. Thank you.
Thank you. So thanks, Geeta, and excellent timing. So we have 10 minutes for questions. So, Peter.
Geeta, really lovely job.
Thank you.
Just a quick question on that adaptation possibilities. Had you thought about whether there was possibility of altering the rotation, say replacing black gram with a different legume or something like that? Maybe that's impractical. Is that an option?
Yeah, you mean to say changing cropping pattern itself, or yeah, that we can also think of.
And maybe substituting different crops, and so moving from black gram to
alternate crops.
Yeah.
Yeah, we can think of that as an adaptation technology.
Would you tell us in few words the cooperation of the farmers or their response or their views in this program?
Definitely, when we want to go with the field trials, when we want to engage the stakeholders, farmers will definitely be a part of it. So none of the field trials we are planning in the research station or something. We would be always engaging with the farmers. Almost all of our the ongoing projects also we are doing it only at the farm level. So we will take them definitely on board so that they will be part and parcel of the system. So whatever the adaptation technologies we develop, that will be definitely adapted by them and they are part and parcel of the system. So we definitely have that in mind. Yeah.
This is a question about the interpretation, which, admittedly, I also am working to understand. I'm looking at John. So when you're comparing Tamil Nadu with Andhra Pradesh, and when we look at the relative yield distributions, it seems as if Andhra Pradesh, in terms of the crops, the relative yield factors were, that it was, it seemed more negative. This one. But then, when you look at the gainers and losers for both systems, in terms of the percentages, they're really quite close. So, what is it in the economic system that is adjusting to, is this a valid question, John, for interpretation? What is it in the economic system that is compensating in Andhra Pradesh to make the gainers and losers actually about equal? Is that the interpretation? Is that an interpretation question?
Yeah, definitely. And, well, I'd actually like to ask the team.
Yeah. So maybe our PA would like to answer for that as well.
Oh, for sure.
Sorry to interrupt. Could you go to the next slide? Really on that one.
Yeah, so that's my answer, yes.
Okay, thank you. And now,
You want to answer?
You want to add up to?
So in both cases, we have considered only the major crop and other activities, other crops. In Tamil Nadu case, there are 3 or 4 other crops like pulses, sugarcane, chai in some cases, second season. So we have, grouped them together. So, and we have assumed the consistency for the both systems. Probably if we disaggregate that and add them to the, and probably little changes may be there. I think that we will take care of when we are doing the extended analysis.
Yeah, basically if we divide it into different strata, there may be a clear indication coming up. But since because the sample size is too little, we couldn't stratify the sample. So maybe in the stretched analysis, we will stratify the samples and we will do it. Yes. Yeah.
Geeta, excellent presentation. I have a question on climate part. You have shown minimum temperature, but maximum temperature is not shown.
Yes, sir. Yeah.
Is there any particular reason?
Yes, sir. As I indicated in the beginning itself, we find that the correlation between the yield and the minimum temperature is better compared to correlation between the yield and the maximum temperature. So I just wanted to, we just decided to project it in terms of minimum temperature rather than the mean or maximum temperature.
and why is that?
Probably our area, the night temperatures are rising now and that's having a real impact on the
Respiration.
yes, yeah. Nighttime respiration is increasing, so that decreases the yield of the crop.
Yeah, Geeta, could you go back to that other question we had, the table where you had the results? Yeah, on that one, I mean, since there are, what the comment was that there are other components of the system that are contributing to gains and losses. And I wonder if it would be useful to put all of the system components on this slide so that you can see in one place what those all are. Because if this is an incomplete picture, it's really easy, I think, to misinterpret the result. Is that possible to put those other components in?
What do we look at? It's a question actually. What do the economists need to look at
Great.
and the crop need to look at? The crop is up there, they can put it up, but it's not explanatory to the actual.
Right, I think this analysis, though, The only thing that's changing here is the one crop. Is that right, Perhaps? In this particular analysis, it's just the one main crop that was modeled that's changing here. So this does represent what's changing. But if we had other model components, you're right, it would be interesting to show what was assumed for those other model components. And yeah, that's why I think, in fact, we need a more elaborated table with for each, case we do, the key, parameter, if you want, assumptions or parameter values that are going into it. So if there were a livestock component, for example, we'd want to know what was assumed or what was modeled in terms of the change in livestock productivity as well. But could you pop back up that relative yield distribution picture? So, when I look at the Tamil Nadu, the Tamil Nadu one, a couple of things we were going to talk about. There's that one real outlier down on the negative tail. But then I believe the one value is right there at the right side. So it looks to me like what's happening then is that, and I can't read the scale. What's that lowest value, Peter? 0.5. That's 0.5? Oh, okay. I see. No, it's the horizontal scale. Yeah. So the far left value is, yes, 0.7. Okay, yeah. So you can see that, everything's on the left side, but in fact, if you take out that one outlier, the CV is really small. And so what we're generally seeing in a lot of the simulations people have done so far is that we're really getting a very, very small variance of the relative yield distribution. Remember that one I showed you from the US? We had, the CV was much, much larger. So this again goes back to the point about the small number of observations we're using, but it's more than just that. What's really going on and what we have to think about is, are the data we have representing the heterogeneity that's out there so that it can be captured in the climate simulations? Because, in other words, just because I have 60 data points, if I have one weather station and 2 soils, I'm not going to see much happening. That's a really crucial thing we have to think about. That's a real challenge with the data constraints we face.
Okay, one more comment on this. So even though the distributions look quite different, when they're represented in the R value on the next table, they're actually very similar.
Right.
So exactly. So it's quite.
Yeah, and I mean in that table we should have a mean and a standard deviation probably, but this is a better way to look at that.
Yeah, but also when we get but then what actually
So I have one,
That's right.
one more comment.
Neither of them is showing much variation. Even though they don't, you could say these don't look very normal. You could say. Yeah, sorry. You could say these don't look like normal distributions, but in fact, if you look at the scale on the horizontal axis, these are very compressed. That's the point. Yeah, that's the key point.
Yeah, I wanted to also say, because I noticed that one on the right side as well, and it makes me wonder, when we show these curves, we are very interested in that crossing point, which is where we get that 54.7% and 53.2%, I believe. But I think the integration, the net losses are also quite important. I did see them on the table on the next side, and I want to just, or the net change there is losses in these cases. So I think that is another number to really kind of underscore and show, because that in many cases is a bigger impact, especially when you have this broad distribution. That crossing point becomes less important than the accumulated underneath.
So that is actually two different ecosystems. The consistency is more in rice ecosystem because it's purely irrigated, and the Andhra Pradesh case is purely rain-fed. So that's why you found the distribution. So that's the main reason. And even if you see the yield levels, they are widely varied. So that way the compensation might have taken place. So that's why gainers and losers are more or less same in both the systems. But you can't compare this particular irrigated ecosystem with the rainfed ecosystem. So that is the main conclusion from this particular graph.
All right, thank you. Any last question before we move on to the next presentation?
I think our PA wants to say something.
So this relative yield distribution is basically the ratio between simulated current yield and simulated future yield. And as I already mentioned, we have included the change future system represents only the change in price a single crop alone. So there are other crops, and the total contribution of rice to the entire household income is only about 40-50%. I think when we introduce other crops also in our analysis, and if we introduce the rats and other things, if there are likely changes in the other components. So definitely there will be some changes in other components as well in future. So when we introduce and when we do the extended analysis, probably we will be able to better capture. So this represents only 30 farms, and as far as the rice is concerned, we have taken the data from the ongoing scheme. So these 30 farms are relatively clustered around 2 or 3 related villages. So it is a cluster sampling. But our extended analysis will be including more clusters from different villages. I think we